Chapter 6. 4 Simple Reinforcement Schedules. The definition of reinforcement schedule in our textbook is a rule that states under what conditions a reinforcer will be delivered. Another way of saying that, from Michael Domyan's Principles of Learning and Behavior, is a program or rule that determines which occurrence of a response is followed by a reinforcer. Recall from Chapter 5 that a reinforcer is a consequence or outcome that strengthens or increases the likelihood of the behavior that produced it. For behavior analysts, there's an important distinction between a reinforcer and a reward, but it's not covered in our textbook until Chapter 7. So for now, you can think of a schedule of reinforcement as a rule that specifies when a behavior is rewarded. The reinforcement schedule has a big impact on how quickly operant responses are initially learned and when and how they occur once they've been learned. This is important because different schedules of reinforcement maintain different rates and patterns of responding. The 4 simple schedules of reinforcement covered in this video are fixed ratio, variable ratio, fixed interval, and variable interval. Notice there are 2 types of schedules, ratio and interval, and 2 types of reinforcer delivery, fixed and variable. In ratio schedules, reinforcement depends on the number of responses. In fixed ratio schedules, the rule is that reinforcement is delivered every n responses every time, where n is the number of responses required. If a pigeon is pecking a key for food in an operant chamber on a fixed ratio or FR20 schedule, food will be delivered after every 20th peck, no matter how much or how little time that takes. On an FR100 schedule, food is delivered after every 100th peck. On an FR2 schedule, food is delivered after every other peck, and so on. Here's a typical cumulative record for a fixed ratio schedule. In fixed ratio schedules, the faster the pigeon pecks, the more food it earns. So we tend to see bursts of responding at a high rate until the reinforcer is delivered. Each reinforcer delivery is indicated by a pip on the cumulative record. After reinforcer delivery, we often get post-reinforcement pauses, periods of no responding before the next burst of responding begins. Mazur calls this pattern of high rates of responding followed by reinforcement, followed by post-reinforcement pauses, a stop-and-go pattern. In the textbook, Mazur described piecework in a factory as a fixed ratio schedule. Customer loyalty cards are also an example of fixed ratio schedules. If you buy 10 coffees from Cafe Nero, your next one's free. The operant response is buying a coffee. The reinforcer is a free coffee, and the schedule of reinforcement is FR10. Of course, there's also another schedule operating in that situation. Every time you buy a coffee, the operant response of buying a coffee is reinforced with receiving a coffee. That is continuous reinforcement, also known as FR1. The rule in variable ratio schedules is that reinforcement is delivered after a variable number of responses. A different number of responses is required to obtain successive reinforcers. If a pigeon is pecking for food on a key in an operant chamber on a variable ratio or VR20 schedule, there's a particular response requirement, a specific number of times the pigeon must peck the key before food will be delivered, but that number changes every time. The response requirement could be 20 pecks for the first reinforcer, but only 1 for the next. That's what makes it variable. The number 20 in the variable ratio 20 schedule tells us that the average of the response requirements for all reinforcers would be 20 pecks. So we know that a VR40 requires twice as much work, that is, twice as many responses, as a VR20 on average. That doesn't mean that the response requirement for the VR40 will always be higher than the requirement for the VR20. Here's a typical cumulative record for a variable ratio schedule. Once again, the faster the pigeon pecks, the more food it earns, so high response rates are common. With variable ratios, reinforcement is unpredictable from the pigeon's perspective. The next reinforcer could be 1 response away or 100. Under these circumstances, pausing at any point is not unusual. Mazur calls this pattern of responding fast and steady. Variable ratios abound in gambling, sports, and video games. If you can't tell when the next reinforcer will occur, but you know that the more you play, the more likely you are to win, that's a variable ratio schedule. Slot machine gambling is a classic example. The operant response is placing a bet, which costs money, and the reinforcer is winning money. Sooner or later, the machine will pay out, but you never know how many more responses will be required or what the payout will be. One thing you can be sure of is that the house always wins. In interval schedules, reinforcement depends on the timing of responses. In fixed interval schedules, the first response after a certain amount of time has elapsed gets reinforced. If a pigeon is pecking a key for food in an operant chamber on a fixed interval or FI 20-second schedule, and it's important that we specify the units, whether it's seconds or minutes or days or what have you, 20 seconds must pass, and then the pigeon must peck for food to be delivered. There's no incentive for the pigeon to peck a whole lot. Until the 20 seconds are up, pecks have no effect. And then as soon as the 20 seconds are up, the pigeon only needs to peck 1 time, so it doesn't need to peck at a very high rate. Of course, the pigeon doesn't have a watch or a cell phone and can't set an alarm for 20 seconds. Without some kind of cue, it can be difficult to tell when time is up. Once a pigeon has a lot of experience with a fixed interval schedule, the typical response pattern is this. Little or no responding at the beginning of an interval, that is just after food was delivered, with responses becoming more and more likely the more time passes. In the textbook, Mazur calls this an accelerating behavior pattern. Human behavior on fixed interval schedules is often complicated by the fact that we can take advantage of watches, alarms, and other cues that aren't available to other animals. However, sometimes our behavior is governed by fixed interval schedules in spite of those cues. When waiting for a bus, the operant response might be going outside to look for the bus at the bus stop. The reinforcer would be the bus arriving and letting you get on so you can get wherever it is you want to go. Looking for the bus before it arrives doesn't do you any good, but you can't get on the bus if you don't know that it's there, and you wouldn't want it to leave without you. You're probably unlikely to get up and check for the bus when you know it's supposed to be 10 minutes away, and much more likely to get up and check if it's a minute or 2 away. Finally, with variable interval schedules, the rule for reinforcement is based on the amount of time that has passed, but the requirement changes from one interval to the next. For a pigeon pecking a key on a variable interval or VI 20-second schedule, the requirement could be 6 seconds for the first reinforcer, then 30 seconds for the next. The 20 seconds part tells us that the average of all the intervals in the schedule is 20 seconds. So we know that in the long run, a variable interval 40-second schedule will produce half as many reinforcers as a variable interval 20-second schedule, because on average, the intervals are twice as long. But some of the intervals in a VI 40-second schedule will be shorter than some of the intervals in a VI 20-second schedule. Here's a typical cumulative record for a variable interval schedule. The timing of reinforcer availability is unpredictable, so responding tends to occur at a pretty steady rate with no bursts and no pauses. Very low rates of responding could lower the rate of reinforcement. For example, on a VI 10-second schedule, a pigeon can earn 6 reinforcers per minute. But if the pigeon only pecks once per minute, it will earn at most 1 reinforcer per minute. Beyond a minimum response rate, however, increasing the response rate doesn't increase the rate of reinforcement. In other words, in a variable interval schedule, there is an incentive to respond regularly, but not necessarily to respond a lot. Mazur calls this a slow and steady behavior pattern. As Mazur suggests, checking your mail is probably reinforced by receiving mail you actually want on a variable interval schedule. The operant response of checking mail, whether electronic or snail mail, is probably reinforced by receiving mail you actually want rather than junk mail or bills. The response is required for reinforcement to occur. Mail sitting in your inbox or your mailbox doesn't influence your behavior if you don't know it exists. The schedule is variable because sometimes you probably get lots of interesting or useful mail and other times just junk. To recap, in ratio schedules, the rules about reinforcer delivery are based on the number of responses. In interval schedules, they are based on the timing of responses. Fixed schedules are predictable because the rule stays the same from one reinforcer to the next. Response rate is low when reinforcement is unlikely. That's the post-reinforcement pause in a ratio schedule, fixed ratio schedule, and the beginning of a new interval in a fixed interval schedule, and high when reinforcement is likely. Variable schedules are unpredictable because the rule changes from one reinforcer to the next. This produces a regular responding.